Welcome back to the deep dive. Today we're jumping straight into what might be the biggest bottleneck in LLM development. We're talking about data, how we actually feed these massive models. Our whole mission today is to simplify the really complex world of data preparation. I mean, if you've ever tried to replicate a training run for an LLM, you know the pain. Our sources point out that right now most data prep relies on, and I'm quoting here, ad hoc scripts and loosely specified workflows, which is a very academic way of saying it's a complete mess. It means poor reproducibility and, frankly, a huge waste of time.
It's a huge waste, and that's exactly why we're focusing on this new framework, DataFlow. It's designed to be this unified system for data prep and workflow automation. The whole point is to cut through that chaos and focus on data quality and, maybe even more importantly, reproducibility.
Okay, let's unpack that. So DataFlow moves beyond scattered scripts. It uses these things called system-level abstraction.
Yeah.
But is that just a fancy term for, better commenting in your code? Or is there a real engineering benefit here?
That's a great question. And yes, the benefit is absolutely real. Instead of brittle one-off code, you get these modular, reusable, composable transformations. Think of it like using standardized Lego bricks instead of having to weld custom metal parts for every single project.
Okay, that Lego analogy really helps.
And on top of that, it gives developers a PyTorch-style API, which means your data flows are suddenly debuggable and optimizable, just like your models.
That sounds way more robust. And to give you a sense of the scale here, we're not talking about a small tool. The framework has nearly 200 reusable operators and 6 domain general pipelines.
And those 6 domains cover a ton of ground. We're talking text processing, mathematical reasoning, code generation.
Text-to-SQL, agentic RAG.
Exactly. And even large-scale knowledge extraction. It's incredibly versatile.
So here's where I think it gets really interesting, the automation part. The Data-Flow-Agent. How does this thing actually work? How does it handle the complexity of 200 operators and turn a simple request into code?
The agent is really the key to usability. It's designed to translate a natural language request, something like, hey, clean this text data, remove personal information, and format it for a math problem. And it turns that directly into an executable pipeline.
Okay, but how? What are the steps?
It's a 3-step process, really. First is operator synthesis, then pipeline planning, and then the crucial part, iterative verification.
Let's pause on that one. What does iterative verification actually mean in practice?
It means the agent checks its own work. It's like having a programmer who self-corrects. It makes sure the pipeline it built actually does what you asked for in plain English. That's vital for trust.
Got it. So it's not just generating code, it's validating it.
Precisely. And this whole system supports both open source and locally deployed models, so you aren't locked into some proprietary API. Which, of course, brings up the most important question of all. Does all of this structure and rigor actually pay off? Does it improve the final LLM's performance?
And the numbers are pretty surprising. The answer is a clear yes. For instance, up to a plus 3% execution accuracy in text-to-SQL. Over a specialized baseline, too. That's huge.
3% might not sound like a lot, but in a business context, that's a massive reduction in failed database queries.
Right. And we also see a 7% average improvement on code benchmarks and 1 to 3 point gains on really hard math tests like math and GSM-8K.
But the most compelling result, the one that really connects all the dots, is about quality versus quantity. Using DataFlow, they created this high-quality 10,000 sample dataset, and a base model trained on just that small dataset was able to surpass models trained on 1 million samples of lower quality data.
1 million. So we're talking about a data set that's 100 times smaller being more effective.
Exactly. It's the clearest proof I've seen that quality demolishes sheer quantity.
So we're moving past this era of just throwing messy data at a model and hoping for the best. It sounds like DataFlow is establishing a practical, high-performance way to do this reliably, reproducibly, and at scale.
It really is. And it leaves us with a final thought to chew on. Given that we now have proof that a small 10K sample dataset can beat a massive 1 million sample dataset, how fundamentally will this shift AI development away from brute force scale and toward, precision data engineering?
A very important question. We'll leave you with that thought. We'll see you on the next deep dive.